Pulleys. Pulleys are used basically to drive the belt and impart the necessary tension to it. An endless moving belt requires at least two pulleys at each end, at head and the tail ends. The pulleys are of welded steel construction and normally made of a mild steel. The pulleys shall be connected to two hubs, one at each end, with the help of two diaphragms. For bigger pulleys, a third diaphragm in the middle of the shell is used, which stiffens the shell against the buckling. Hubs and diaphragms are accurately machined to ensure concentricity. Pulleys are strictly balanced. All head and driving pulleys are crowned to encourage the centering of the belt. The pulley shafts are made of carbon steel, and the mountings of pulleys to the shaft are of shrink fitting and keyed and are designed for strength and the rigidity. The rubber lagged pulley are used in order to increase the friction factor between the belt and the pulleys. The lagging can be plain or having a grooves running crosswise or in a herringbone. Driving unit. Driving unit generally comprises of a squirrel cage motor, worm reduction gear, fluid coupling with a flexible coupling between the reduction gear and the driving pulley of the conveyor and between the motor and the reduction gears. The flexible couplings are to cope with the slight misalignment with the provision of fluid coupling on input side. The motor starts under the no load conditions and conveyor moves only when the motor reaches its full speed. This also eliminates the starting shock on the conveyor components. Different conveyor stages have different driving units with a motor capacity varying from 30 horsepower to 150 horsepower depending upon the length and the inclination of the belt section. Usually 415 volt motors are employed, having the speed of 1440 rpm. The brakes are fitted to the conveyor drive system to stop the belt as quickly as possible when the supply to the drive unit is interrupted. This avoids a build-up of coal at transfer point and prevents the belt from running back. The brakes are also serve to minimize the risk of injury to a person if the belt is stopped in an emergency. A brake is usually located between the fluid couplings and the gearbox, and for inclined conveyors, hold backs are provided in the gearboxes to prevent the runback of the conveyor under the loaded condition. The belt cleaners. The belt cleaners or scrapers are used on the conveyor belts to remove the coal particles from the belt surface after the main coal flow has been discharged. If this is not done efficiently, deposit of hard coal could occur in different parts of the conveyor system. These deposits would cause uneven belt running and increased maintenance work, and so shorten the life of the belt. A V-type internal belt cleaner made of MS flat and hard rubber strips are provided to clear the internal surface of the belt. One type of scraper has replaceable non-metallic blades which are held by spring-loaded shaft on the belt, and another type of scraper consists of a tensioned wire held by adjustable braking over the top of the belt. Both type of belt cleaner are very effective in removing the hard deposit which can build up on the coal conveyors. It must be ensured that the scraper is held against the belt with any sufficient pressure to remove the material without causing a damage to the belt, which is possible if excess force is exerted by the wiper blades. Now take-ups. New belt stretch during their early operating life, so it is necessary to make the allowance for this if the maximum life is to be obtained from the belt. Take-up gears actuate one or more pulleys to adjust the tension. Take-up on the conveyor belt is provided for the following purposes. First, to maintain the slack side tension necessary for the drive to operate the belt. Second, to keep the sag of belt between the idlers at the point where required. Horsepower will be at minimum and load will be moved with the least disturbance over the idlers. Third one, to permit the length variation due to the belt stretch and shrinkage. Fourth, with the gravity type of take-up, some of the starting shock is removed from the belt. When it is possible to provide an extra long take-up movements, the additional belting will be available for replacing. These are two general types of take-ups. One is manually adjusted, that is screw type, and second one is a automatic or a gravity type. On shorter conveyors, screw type tension gear is frequently used. This takes the form of two large bolts, then can be screwed in and out to move the head or rail pulleys horizontally on their pedestal. In automatic take-up, the theoretically required minimum amount of belt operating tension and can be continually provided even when belt stretch or shrinks. Any stretch or shrink is taken up by the use of gravity take-up towers, especially on the long conveyors. And the principle of this device, the downward force of the counterweight on the tension pulley maintains the tension in one type with 180-degree wrap on the take pulley, and the take-up pulley bearings are mounted on the yoke, which is moved vertically along the two post guides. Extra weight is added to the take-up box is required, and care should be taken to use just enough weight to produce a proper tension on the belt. Any dust, spillage or other accumulation on the counterweight should be cleaned periodically. Apart from the above mentioned parts, substantial fabricated frames, hoods and stands to support the heavy component like pulleys, take-ups and drive mechanism etc. are required. Galleries and walkways are provided on both sides of the conveyor belt run to have the access to the defective part for the maintenance and for normal checking of its operation. Belt covering is provided to safeguard the equipment against weather and natural calamities. Also, the chutes are required at transfer points. Deck plates between the carrying and return stand of the belt ensure that spillage do not take place on the return belt. Now, accessories of a conveyor belt. Various switches. Pull wire switches are mounted on one side of a walkway of each conveyor at approximately 24-meter intervals. The switches are connected by a pull wire which is easily accessible along the entire length of the conveyor. On emergency, it can be operated from any point to stop the running of belt. On operation of the latch lever on the switch remains in lock position and it has to be put to unlocked position before starting the conveyor. The belt stay switch is also operated when conveyor tends to sway beyond the permissible limits. These are usually spaced 50 meters apart. Now, zero speed switch prevents the motor from burning under the stalling condition in an event of overloading or the jamming of the conveyor belt. De-interlocking switches are provided to remove the interlocking of a particular equipment and auxiliary for running it on the trial etc. basis. Now, flap valves in bifurcated chutes are motor driven, though a suitable reduction gear and actuated by remotely controlled switches. A flap limit switches are provided to control the over travel of a flap wall. Also, the stoppage due to the pulley or the pulling rope switch, the conveyors which are behind that accidental belt are stopped due to the factor of safety of input is close to the next succeeding belt, and the whole thing is stopped for the safety. Now, magnetic pulleys. The belt conveyors before feeding coal to crusher are provided with the high intensity electromagnetic pulleys complete with the spherical roller bearing pillow blocks for spreading out the tramp iron particles and pieces from the main stream of coal conveyor and capable of removing from coal size of 300 mm. A suspension type electromagnets. A suspension type electromagnets of a high capacity are used for separating the tramp iron pieces from coal. Suspension type electromagnets. Suspension type electromagnets of high capacity are used for separating a tramp iron pieces from coal. Magnetic impurities or a tramp iron consist of a great variety of objects like belt, nuts, bars, angle and channel, section of the mild steel, chains, steel ropes, springs, railway buffers, sheet metal pieces, etc. The steel attachment of high permeability alloy steel, which may be collect the alloy, are suspended on the conveyor belt at some convenient location, usually before the crusher. After attracting the magnetic impurities, the magnet is moved out of the belt stream and demagnetized, thereby disenergizing the attracted particles, and the arrangement of the head end and the line magnetic separator as follows. Mouthpieces and isolating gates. The separate direct local telephone system is employed for the coal handling plant in most of the power station. Mouthpieces are installed in the various locations to pass on the message or instruction to operators and attendants working on the different sections of the plant. Isolating gates are provided to isolate the totally cut off the coal supply from one point to another. Now, belt weighing machines. Belt weighing machines are the only practicable equipment to weight the quantity of coal going either to a raw coal bunkers or to a stockyards through a stacking cum reclaiming device. The quantity of coal being reclaimed from the stockyard can also be weighted. Like other weighting machines, they consist of a load reception, load transmission and load equalizing parts, but the load is in motion at the time of measurement. The subsequent dynamic disturbances can cause inaccuracies. A length of a belt conveyor structure is replaced by a weight bridge, which is loaded by the conveyor. A belt carrying a bulk material and the belt weighing machines can be installed on the inclined conveyors with the usual shallow inclination of 18 degrees. Belt weighters are either in totalizing type or an integrating type. In the totalizing type, weight or the weighing cycles are added up in series, while the integrating type obtain the whole weight by integration. The individual cycles of the totalizing type flow each other, and weight of each cycle is added to the sum of the weights of the previous cycle. Now, belt swaying. The sideway vibration of the belt is called a belt swaying. Reasons for belt swaying is the conveyor structure is not properly fixed or aligned. Second one is the eccentric loading of the belt, that is coal not falling on the contact of the belt. Third is the idlers not aligned properly. All should be in a one vertical plane. Coal dust stacking and building up on the idlers. These defects should be rectified to prevent the swaying. Also, the self-aligning idlers are provided after every 9 rollers. The belt swing due to the eccentric loading can be prevented by providing a deflectors in the chute or centralizing the feed. The belt stoppage are also provided to stop swaying. In case of swaying exceeds a certain limit, the limit switches gives excessive sway alarm and trips the belt. Protection system of the conveyors. In addition to the conventional protection provided in the MCC for the safety and the motor and the system as whole, the conveyors have been equipped with a certain protections against the local mishappening injuries to human being working in the vicinity or the equipment itself. First, pull cord switches. It is protection for stopping the conveyor locally by the operator in case of any emergency or a potential damage. These switches have been provided at approximately 30 feet gap along the length of the conveyors and have been fitted on the structure carrying the conveyor. With the switching of any of these switches on the conveyor will become immediate halt tripping, concentrating the interlocked system also. The conveyor cannot be started unless the switch has been reset. All conveyors are equipped with this protection, which consists of normally closed contact in the control circuit. Now belt switch. Belt sway switch. It is very important for the safe and smooth running of the conveyor on the throwing rollers which without any side swaying. This will prevent the edge wear of the conveyor as well as the spillage of the coal. In addition to the throwing roller on which the conveyor travels and the self-aligning rollers which try to keep the conveyor in center. Special vertical rollers on the both sides of the conveyor with the belt sway switch in the center below the conveyor have been provided at regular span. When the belt sways abnormally to any side, it hits the special vertical rollers and pushes backwards. A limit switch registers and back travel of the complete roller assembly and operates at a present value to energize the belt sway switch, tripping the conveyor motor. Before the conveyor is started again, the reasons for this abnormal swaying of the belt is investigated and the needful done for rectification. For resetting of the belt sway switch, a red push button has been provided near the conveyor motor at the head end, which is kept pressed while giving a starting command to the motor. This pressing in fact bypasses the belt sway switch protection and the red button is released only after the conveyor has attained the normal speed with no abnormal swaying. In case of the swaying still persists, the operator is supposed to release the red push button after the reasonable time allowance and the motor is allowed to again to trip on the belt sway protection. Speed monitoring switches. In the coal handling plant, all interdependent conveyors should run on an equal speed. This is important to avoid a build-up of pile of coal on any conveyor or empty running of the belt. Speed monitoring switch have been incorporated to provide a protection against the reduction in the speed of the conveyor due to any reason. Speed loss may result either in insufficient or inefficient coal handling or damage to the equipment, that is belt, motor, etc. And the protection consists of a speed monitoring electronic switch fitted on the conveyor pulley to monitor its speed. As soon as the belt speed goes down to a preset value, the speed monitoring switch gives the tripping command to the conveyor motor. However, for startup purpose, provision has been made to bypass the speed monitoring switch through a timer to facilitate initial building up of the speed of the motor. Now, interlock and de-interlock switch. Each conveyor has been equipped with an interlock and de-interlock switch fitted on the panel at the head end of the conveyor. This comes handy while running the conveyor for testing or on non-load trial run without interfering with the other running conveyors. This switch will defect all plant premises of the conveyor provided the control circuit in an healthy condition. Triplus. The coal from crusher house is transported to a bunker bay with the help of conveyors. From the conveyors, coal is discharged into the bunkers with the help of triplus. Conveyors and chutes are fitted with it to carry the coal up to the desired location. The triplus is provided with the wheels which moves on the rail and parallel to the conveyor on each side. It can be set in one position or to be made to travel slowly backward or forward between the stops to discharge the required quantity of coal at a desired location. The motorized triplers are usually used where the continuous and uniform distribution of coal along the conveyors is required or where the frequent forward and reverse movement of the tripper is required. Trippers have a rigid welded steel frame to resist a shock and minimize the distortion. One-way or two-way discharge chutes are provided as required. The flap dampers on the buffering or bifurcating chutes permits the flow and discharge of material to the desired side. The tripper travel is rated about 30 feet per minute. The wheels and the pulleys on the tripper, including the trunnion, are provided with the anti-friction bearings and do not require much attention by way of lubrication except the occasional checkup and greasing. Sizing system of coal. Sizing operations at coal handling plant consist of removing a large impurities by use of simple grills, sizing of coal with the help of screens located before the crusher and then crushing in crushers to size the coal for pulverizing. As a first step in sizing, the coal grills are provided at unloading hopper where the coal lumps of a larger size than 200 mm are retained on it and rest passes on the conveyor belt underneath. Big lumps are broken manually by hammers and made to pass through the grills. The grill is fabricated from the rolled steel bars and flats. The screens are located before the crusher to bypass it from the smaller particles which would otherwise overload the crusher, or a large capacity crusher would be needed unnecessarily. The screened coal of small size up to 20 mm need not be crushed, so it is bypassed from the crusher and fed directly to the conveyor, from where it is fed to the bunker. A vibrating screens are gravity fed type, the screen being stopped or sloped downward from the fed to the discharge end, and the high frequency low magnitude vibration is given to the screen by electric vibrator and or other means. The purpose of the vibration is to keep the meshes clear of wetted particle and stratify the coal so that the fine particles come down in the contact with the screen. In a typical coal handling plant of 200 megawatt units has two vibrating screens are installed before each crusher. These are double deck vibrating screen of 250 mm size at upper deck and 100 mm size at bottom deck, and are fixed on springs and connected by a shaft through a cam which is driven by a motor. The upper deck is a trash screen which rejects a large pieces of foreign matter to a chute leading to a suitable receptacle while allowing the passage of coal of minimum minus 250 mm size. The lower deck is sizing screen, and the coal of minus 100 mm size passing through it bypasses the crusher and joins conveyor belt on the discharge side of the crusher. The coal above 100 mm and up to 250 mm size flows to the primary crusher, where it is crushed to 100 mm size, and coal of a minus 100 mm size is sent to secondary crusher for further crushing to 20 mm size. Now crushers. There are two different types of crusher. First is a primary crusher and second is a secondary crusher. In first primary crusher is a slow speed single roll machine. Crushing come off mine, that is ROM, run off mine coal to 100 mm size at the rating of 300 to 400 tons per hour. This single roll crusher basically consists of crushing roll, breaker plate assembly, and a power transmission unit. The roll is equipped with a teeth designed to force the coal against the breaker plate or wear plate to produce the crushing action. The roll is connected to a motor by V-belt and gear drives. The main element of this type of crusher are illustrated. The roll crushers the material with a combination of impact and shear and compression to give the fast, snappy crushing action and high capacity. Firstly, tooth segments on the roll shell strike the large pieces, reducing these intermediate size lumps. Next, the hard faced portion cleaves or trim with the shearing action as the feed is trapped against the breaker plate. Finally, the remaining uncrushed coal is broken when compressed between the lower edge of the breaker plate and the cylindrical roll shell face. This triple action crushing results into the uniform product containing a minimum of fines and oversizes. The crushing zone curves downwards from wide operating that takes big area to a construct but adjustable discharge openings. Product size adjustment. The product size can be adjusted by position of a breaker plate, which can be changed by adding or removing a shims from the back of toggle mechanism. Jacking screw on the back of the frame provides the force to move the toggle mechanism. Now overload protection. The automatic spring-loaded toggle mechanism holds the breaker plate into the position against all the normal crushing loads, but allows it to swing back from the roll shell to pass a large impurity such as tarponium, mine timbers, and other uncrushable material to prevent the jamming of the crusher. The springs automatically return the breaker plate to a crushing position when the uncrushable material has passed through a crushing area. For removing the foreign material from the finished product, the motor relay can be set to kick out and stop the feeder and crusher when toggle action